Insole wall is a lightweight, interlocking, expanded polystyrene form which is used to construct a continuously insulated structural wall. These ICFs, insulated concrete forms, provide a formwork system into which concrete is poured. The wall can then be finished by externally using render, cladding or brick slip, and internally using conventional plasterboard. Insole wall insulating concrete forms offer many advantages over conventional forms of construction, due mainly to its innate strength, inbuilt insulation, and monolithic construction, offering increased design flexibility, thermal performance, and air tightness without the need for additional site operations. The insole wall ICF system is also a perfect watertight solution for basement construction, where there is no need to parge coat the internal skin of blockwork to provide superior air tightness, and no need for additional insulation and wider cavities to achieve a code level 4 wall structure. The 100mm core capacity of the insole wall ICF system also uses 1/3 less concrete than other ICF systems. Whilst thermal bridging is a major issue with other forms of construction, our system typically achieves an exceptional design Y value of 0.013. A completed project using the insole wall ICF system has a Code for Sustainable Homes Green Guide rating of A+. Using the insole wall ICF system, high levels of sound performance can be achieved due to the dense nature of the concrete core. Other benefits include fast-track construction, reduced manual handling, and less waste disposal. On this particular project, insole wall is also being used to form a watertight basement, as well as the main external structural walls of this 3-bedroom property. Although insole wall can be constructed on any concrete base, this particular project utilizes our insole slab foundation system. In basement installations, additional vertical rebar starters are required to tie the ICFs to the concrete base. A standard ground floor only installation would require no further reinforcement, as the ICF system would simply sit directly onto any concrete slab foundation, such as insole slab. Whilst there are various waterproofing methods, this particular scheme involves installing a water bar bead into a pre-made recess in the insole slab floor finish. This reacts to the water content in the concrete mix and expands to create an upstand to resist water ingress at the junction between the floor and basement walls. Combining this with a waterproof admix within both the concrete pores of the basement walls and floor slab provides a fully guaranteed waterproof structure. Once the initial setting out of the floor channeling is complete, the ICFs simply sit in the channel and interlock together using the optional locking bars. The blocks can also be easily cut to fit any dimension.
From this typical installation, as you can see, it's a very simple process. It's quite a quick process. The guys have only had a day in the classroom doing some theory training and half a day on site. The actual installation of the walls has only taken 5 days, and it's been 2 weeks lead-in time from foundation level upwards, including the excavation. Once a slab foundation has been laid, our first job is to set the walls out. And as you can see down there, at the moment, there's some tracking down. Once we've measured where our setting out goes, we need to make sure that all of our tracking fits to a multiple of 25mm. This is just to allow our interlock to work, so it all fits together like big Lego bricks. And all the formlock does, the tracking you can see down there, is it just holds the wall in place whilst you're building it. It keeps it straight, keeps it level, and you can take out any discrepancies within the slab within that tracking.
Depending on the structural engineer's design, each course of ICFs can be reinforced using either a combination of vertical and horizontal rebars, or a more simple combination of vertical rebars and steel fibre reinforced concrete for basement walls. Minor rebar details are used above ground floor level.
We then add our bracing system. It aligns and plumbs the wall, so it keeps it straight, not only while you're pouring, while you're building, and it provides a stable working platform. We can take that up to about 3.5 meters, so you can safely work to 7 courses, and you also pour off of that as well. You pour the concrete into the walls while standing on the platform. Along the top of the wall, you can see there's a protection for the interlock, because this interlock is vital for the next stage of the build. it's what they're going to be laying onto once the floor's in. This will negate the need for any more setting out. They've already spent the time at the bottom doing this, so there's no more time spent levelling in. It's already there for them. Around the outside of the build, you may notice there's some sheets of ply. These are for extra reinforcement in weaker areas. As with any shuttering system, you're always going to find there's weak areas where there's certain details within the build, and it's perfectly normal and acceptable for these to be on. There are starter bars located in the walls at the moment, vertical ones. These will tie the ground floor walls into the basement. Any additional internal blockwork needs to be tied into the concrete core of our wall. This is done with a structural tie. This can either be a fur fix, or in this case we have rebar poking through the polystyrene into the cavity. This will sit between the block coursework, thus tying it into the wall. During the concrete placement, we start from one point and we will move in a clockwise direction, sweeping slowly with a very controlled speed on the concrete pump. We don't want the concrete entering the walls too violently or too quickly as to cause any damage to the forms at the bottom of the wall, as it does have about a 3-metre drop. As we pass around the wall, we aim to fill up between 500 to 900 millimetres up from the bottom each time. By the end of the first concrete wagon, we'll have 2 courses of forms filled up. There'll be a wait between the first and second load to allow that first load of concrete to cure slightly, thus reducing the pressure within the wall.
Once the basement walls have been cast and are cured, the bracing and any reinforcement can be removed before constructing the ground floor. The ICF floor form panel provides an ideal interface at the basement to ground floor junction. The watertight external basement walls can now be backfilled to ground level, ready for the construction of the next story. The placement of ICFs for each consecutive story is then simply a repeat of the process of that of the basement, using the same bracing system and allowing openings for windows and doorways to be pre-formed using our specially developed profile. Any service penetrations that are needed are also formed at this point, usually with polypipe, before the next concrete pour completes this story. From foundation slab to first floor would typically take approximately 1 week, including the concrete pour. The floor joists are traditional timber joists, which sit on hangers bolted to a perimeter frame, which has been structurally fastened directly to the ICF system by means of special brackets. Once the property has reached roof level, traditional doors, windows and roof trusses can be fitted. The roof trusses sit directly onto a sole plate fitted into the ICF system. Internally, it's very easy to finish the interior with traditional plasterboard, screwed directly to the insole wall system through special plastic inserts incorporated inside the ICFs. On this particular property, the finish of the render starts with a scratch coat, which is applied directly to the surface of the ICF system, followed by a decorative top coat render product to the main part of the building, with a textured stone effect to the corners and front elevation. Other finishes also include brick render, seen here. We knew we wanted to build using insulated concrete formwork, and ICF Tech were the only company we found that employed installers, rather than farming the work out. Having that continuity and assurance was very important to us. ICF Tech were excellent throughout the process, and I have no hesitation in recommending them. ICF Tech were a pleasure to have involved in our somewhat challenging project. The team were engaging, constructive, and extremely helpful. Nothing was a problem. We're delighted with the result and wouldn't hesitate to recommend them. As a construction professional, the benefits of ICFs are clear to see over traditional methods of construction. Choosing ICF Tech was an easy decision. Apart from their ICF, which outperforms the others, their professional support, knowledge of construction is simply unmatched in the industry.